Welcome to integration involving logarithmic functions. So from the formula sheet, if you have an integral of a fraction, where on the denominator you have the function and on the numerator you have the derivative, then you get log base e of the function, or ln of the function, plus a constant. So we're going to have a look at 4 examples. The first one's going to be an indefinite, so make sure you put the plus c at the end, and the other 3 are definite. So that's where you'll sub in the top number minus subbing in the bottom number. So for our first one, the integral of 4 over x. So using our formula, the derivative of x is 1, and I've got 4. So remember how we've done this before? I only need 1 on the top. So if I've got 4 on the top and only need the 1, then 4 lots of 1 gives me 4, and I'm going to keep the 1 on the top and I'm going to put the 4 out the front. So since the differentiation of x gets me 1, I've got 4 ln x plus a constant on the end. For the next one, so we're integrating from 1 to 5 of 1 over 3 minus 2x. So the derivative of the function on the bottom is minus 2. So I need minus 2 on the top. So just think how you're going to get that. How are you going to get minus 2 on the top when you have 1 at the moment? So to get the 1, minus a half times minus 2 is equal to 1. So I'm going to keep the minus 2 there, and I'm going to put the minus a half out the front. So I put the minus half out the front, and since I now have the derivative of the function on the bottom, I have its derivative on top, I get minus a half ln of 3 minus 2x between 1 and 5. So I'm going to sub the 5 in, minus subbing the 1 in. So when I sub the 5 in, I get minus a half of ln 7, and when I sub the 1 in, I get minus a half of ln 1. And ln 1, you might remember, is 0, so I end up with minus a half ln 7. For the next one, the integral from 0 to 4 of 4 over x minus 1. Now, this requires you to visualize the graph. So this is a hyperbola, and its asymptote would be at x equals 1. Now notice that my integral goes from 0 to 4. So visualize this again. Your hyperbola has an asymptote at 1, and I want my integral to go from 0 to 4. So since this is a special case and the integral crosses the asymptote, it is meaningless, because on either side of our asymptote, we would have an area or an integral that goes to an infinite amount. So therefore, we actually can't do this integral. Just a special case and something you need to just be aware of. For this one, you'll notice that when we differentiate the bottom, we sort of get the top. Like we need 2x on the top. We've got a plus 1. So this one requires us to understand that we can split a fraction into 2. So we're going to split this fraction up into 2, and this is where we'll actually now split it into 2x over x squared and 1 over x squared. So notice that we split the numerator into 2x plus 1. We split it into 2x plus 1, both of them over the x squared. And we're going to consider these separately. The first one is the logarithm, because the denominator does differentiate to the numerator. And the second one, we're going to write as x to the minus 2. So here's our integral from 1 to e. The first one, the x squared, does differentiate to 2x, so you get ln of x squared, minus, because when we integrate x to the minus 2, we raise the power, divide by the new power, so you get minus x to the minus 1. Subbing in e first, minus subbing in 1, we get ln of e squared minus 1 over e, minus ln of 1 squared minus 1. That now gets us So ln of e squared, we can bring the 2 out the front. So that's 2 ln e minus 1 over e plus 1, because remember ln of 1 is 0. And ln of e, so log base e of e, that's the rule that gets you 1. So I get 2 plus 1 is 3 minus 1 over e. Finally, for a harder example. So these regularly come up in HSC or trial papers. So you're asked to differentiate, and then using the derivative, you then look at how you can then integrate. So we're going to differentiate x ln x. And hopefully you've recognized that that is a product rule, x times ln x. So we get x times 1 over x plus ln x, and we get our derivative is 1 plus ln x. So now if I want to differentiate or integrate ln x, remembering that x ln x differentiated to 1 plus ln x. So I've got the ln x, so I need to add 1 to that integral, because that's what I can do the opposite of differentiation and get back to that x ln x. So I'm going to change the integral of ln x to the integral of 1 plus ln x, because that first part is what I need. And then I'm going to do subtracting 1 so that it actually still ends up as a balanced integral. The x ln x, or the 1 plus ln x, it integrates to x ln x, and we know that 1 integrates to x. So we get x ln x minus x, and because it's an indefinite, don't forget to put the plus c. Thank you.